Yes, I put a slide in. I never put these slides in, but I put this in for fun. So I was actually born in Little Rock, Arkansas. Thank you. Graduated from Little Rock Central High. And then I moved to California to work for two startups, Mustang Software and Starbase. And then I joined Microsoft in 2007. And I have to pinch myself every time I think about this because I run the PM team at Microsoft for the languages, runtimes, and frameworks. And there might be some things on the list here that shock you a little bit if you know me. Yeah, obviously C#, F#, .NET, Core, ASP.NET, but there's Java and C++ there. Just kind of weird, the .NET guy, Java. But we'll talk more about that. So the joke, as I think about my job, when I joined Microsoft, I worked on C#. I probably should have worked on Java because we had this thing called Visual J++ in 1997. But we weren't good in open source back then. So we kind of made it a custom Microsoft Java, where we didn't do some of their features and we added some of our own features. And we got sued. And we had to rip it off all the machines. Now, the interesting thing is there's something in there called dubfc, which was Windows Foundation classes. And that is the genesis of actually what is called WinForms in .NET. Basically, we took some of this tech, we wrote a new language, and we shipped it as .NET. And so instead of doing Java, I built C# tools. .NET's old. Shipped in 2002, lots of languages, all about Windows and the web, and that was it. Now, we are also a funny company. As I said, the Java thing was not a good thing. And even .NET, we did some weird stuff. We did this thing. Microsoft plans to shared source .NET. And there's none of that code in actual .NET. It was actually a weird one-off thing meant for educators, but it was not good open source because, as I said, there's not a single line of code probably in that thing that's actually in the real .NET. So that was not good. But we were pretty successful, and I'm going to make fun of this next slide in a second too. So this is a slide that I got from our marketing team maybe 6 years ago. 1.8 billion installs, 64K embedded systems, all this stuff. 6 million professional developers. The funny thing about that number is we didn't know how to count then. So let's go forward. In 2008, we took it a step further. And we open sourced the first parts of .NET. This was MVC, 2008. It was one of the first projects that I worked on. And of course, because we're Microsoft, we can't use like any of the popular open source licenses. We make our own Microsoft MSPL. Good news is it actually was a good license. It's not a bad license. Today we do all of our stuff either with Apache or MIT, but that was actually not a bad license. It just felt weird because we had to make one. You could download the source code, you could redistribute, but we didn't take contributions from the public. Richard and I talk all the time about the work it took to convince our legal team to let us actually take contributions, which took 4 more years. And so in 2012, we really open sourced the tech. We did, ASP.NET Web Stack, Entity Framework, all the parts of the web stack that I worked on at the time, because I was part of the ASP.NET team, we open sourced. And you can see it was amazing on CodePlex because we couldn't do GitHub. And so we were still partially there. And you can see we actually put a proper Apache license on these things. You can distribute the source code. I won't even describe what MS OpenTech was. It was a way to do open source in a company that wasn't ready to do open source yet. But it was a path and it was a way, and we helped the rest of Microsoft be able to start their journey towards that. And then this is my favorite thing. When you have a successful product, what do? You make lots of them. This list is actually embarrassing to me. .NET Framework, Compact, Embedded, Silverlight, Phone 7, 8. And so if you're me, if you don't know anything about me, I'm Scott. And I work for Scott Guthrie, who's the EVP of Azure and other stuff. And so as a Scott, I have to make another one. And so in 2016, we introduced .NET Core, which was the next generation of .NET, meant to take people to the next level, and it was meant to be everything .NET Framework was not. Fully open source, cross-platform, full command line support, all those things. And that's kind of where we are today and where we're at. And this time, we really open sourced all of it with full contributions, and we're one of the highest velocity OSS projects on GitHub today. And this is just a pile of different moments in time that we open source stuff. And I gave up trying to update this anymore because we're so open now, it doesn't really matter. But that's kind of the .NET journey. And there's something else funny about this too is we shipped Java again just a few weeks ago at Build, our developer conference. We now build an OpenJDK, and we build that because we want to make sure that if you're a Java developer, you have a free runtime you can use. Oracle, a couple of years ago, started charging developers for using Java. And guess what? Even though we're a big .NET company, we have things like Minecraft, LinkedIn, Synapse in Azure, all built on Java. And so Java is important both to us and to our customers. And I pinch myself being able to get a chance to work on not just .NET, but Java and C++. Now with that, let's kind of go back to where we are now. And today we kind of live in this world. That .NET Framework world only did desktop and the web. There was no cloud, mobile, gaming, IoT, or AI. Those all came later. A lot of folks didn't even recognize some of this, like Xamarin. That's a company we bought in 2016. That's where the mobile came from. Cloud came from me. In 2010, Scott Gu pulled us out of developer division and brought us into Azure, and so we were there working on some of this stuff. If you've ever run on your phone any app that says Unity, that's a .NET game. Underappreciated how much .NET there is in gaming. With the .NET Core, we actually started working on other processors and stuff and enabling IoT. And we took an open source library inside of Microsoft that we use for a lot of our tools for machine learning, and we contributed to .NET as well. And so now you can build all these types of apps in .NET. This is where it's fun now. Look at my number here. We have greater than 5 million .NET developers in Visual Studio family of tools. Well, what was the 6 million before? Did we lose a million? The reality is, back in the day, when we actually made that other number, we measured our success based on the number of downloads of our product. Today, we actually measure success based on you downloaded it, you installed it, and then you actually used it. And so the number today is more accurate. But I'm happy to say that sometime this year, we will hit that 6 million number again, but this time for real. And just to give you an idea, if you're thinking about how big are developer ecosystems, the estimate is that Java's about 10 or 11 million. And so I think the 5 to 6 million we have is amazing. Number one, love most framework on Stack Overflow 2 years in a row. The one on the right here, the top 30, you can't see the fine print here, but the Cloud Data Foundation, they monitor a bunch of open source projects and looking at how many PRs and how many issues and how many comments are accepted on those technologies. And .NET is currently the #1 project on GitHub on that measurement. And that's because a lot of the contributions to .NET are no longer from us. And that I can't imagine that. 10 times faster than Node.js. If there's any Node people in the room, I'm sorry. This is the perf stuff that we talk about. So as we started reinventing .NET, we have to ask ourselves, well, why would anybody want to use .NET? Back in the day, it was like, hey, if you want to run on Windows, you write a .NET application, but in this new world of all the devices, Linux, the cloud, why would you want to use .NET? And so as we started reinventing .NET, we said, hey, let's focus on performance. Let's make .NET the most performant we can be. And so this is showing a benchmark called the Tech Empower benchmark. There's a bunch of these that they run. This is showing plain text, which is not the most real benchmark, but we have seen all these changes we make for performance actually affect real-world applications. There are plenty of services inside of Microsoft in Azure that have seen 20–25% improvements in performance and cost as they move to the newer tech that we have. On the right side, you can see gRPC, which is something we shipped a couple years ago in .NET. It's a modern messaging framework, and you can see that as we were getting to ship .NET 5, faster than Java, faster than C++, faster than Go, just a little bit slower than Rust, but that was actually running a pre-release version of 5. These aren't our benchmarks, so we have to wait for them to run them, the open community, to see what actually happens here. And so that is our commitment, is to make .NET so fast that it runs better in the cloud for you. This is fun too. As somebody that worked on .NET Framework, I remember having customers call me, and they're on like the version that's 6 years old. And they're like, Scott, hey, what happens if we actually upgrade our server with the new version? Will it break the app? So we had this problem in .NET that nobody used the new versions. They stayed on the old ones forever and forever. And so with .NET Core 3.1, when we shipped it, in the first 6 months of use, we had 3 million people switch to it, or at least use it along with one of the older versions as well. We shipped .NET 5, we had 3.6 million people start using it within the first 6 months. And so this makes me very happy as a developer. People are using our latest bits, the latest technology, the latest stuff, and not waiting 5, 6, 7, 10 years to upgrade. And that's something I would ask any of you, if you're using this tech, get on the newest versions all the time. And this kind of comes down to why .NET 5. So if you don't know, we actually rebranded .NET Core. We took the core out of it, and we went back to just saying .NET. And we did that because we want to make it very clear to our customers that this is the future. The new tech is .NET 5, .NET 6, whatever. And we give you flexible deployment. This solves that problem I said before about .NET Framework. You can have all these versions on the computer at the same time, nothing breaks. Unparalleled performance, that really is the key of our tech. And you're going to see in .NET 6, we want to fix the other part of performance, which we have, which is what we call inner loop. And I'll discuss that in a little bit more. Obviously, with that performance, better hosting costs, and less infrastructure required to run your applications. And then the last line is really more about keeping everything up to date with the latest language features and stuff like that. We're evolving C#, F#, at a faster rate than we ever have. We now ship new versions of each of those every year. And so, if you want those benefits, you need to be on the latest versions of the tech. This is something that, does anybody in the room have any .NET Framework projects? Few hands. So one of the things that people have asked us for forever is, hey, how do you actually upgrade an application faster? And so we actually have a bunch of us at Microsoft that actually take some of our internal teams that are running their services in Azure on .NET and help them move. We've helped some external customers as well. And so we took all the learnings from that. This was a tool that we built for ourselves, and it's now available today. You can grab it, and it will try to help port your application. It'll convert your project files. It'll fix your package references. It'll do some code fix-ups and stuff like that. And it'll back up your code first, obviously. But it's a great way to, if you have .NET Framework applications you want to look at moving forward, it's a great way to try to do that. Now, where are we going? .NET 6. That's the version of .NET we're going to ship this year. And it's actually something I've talked about for a long time, that we've actually finally come together into a single platform. So as we moved from saying .NET, Core 3.1 or whatever to .NET 5, we still haven't put all of it together. If you look at things like Xamarin, that's the mobile tech that we have in .NET. Well, it's a checkbox. It doesn't use the same project system as .NET Core did. It didn't use the same command line tools. We have now simplified all this down into one thing. We're going to have a single SDK that you install, and you can build all those app types I showed earlier. We're going to make the SDK something that's not huge either. You can actually we call these optional workloads. So the Xamarin tech, which will be called .NET MAUI, you can just decide to install it manually. One BCL, this is crazy. We had the .NET Framework BCL, and for BCL, that's base class libraries. That's strings and date times and networking and all that stuff. We had 3 versions of this: the .NET Framework one, the one in .NET Core, and the one in Mono, which ran the Xamarin technologies. We've consolidated all that down into a single platform now. So there's only one set of those, no matter what app type you build, it's the exact same BCL. And we have a unified tool chain as well. There's a command line tool called .NET, and it can build and run all these applications. People have asked for this for a long time. We're bringing cross-platform native UI. This means you can build a single app, and it will run on Mac, Windows, iOS, and Android. And I'm sure people are saying, well, what about Linux? Let me ship the first 4 platforms first, and we can see if Linux actually, there's enough demand for Linux. Obviously, the web is cross-platform, but I say cross-platform web UI because we're going to let you build Electron-style applications. These are desktop applications that use .NET Blazor inside of them. And so you can build a web app that can still access the local file system, local resources. It could load native DLLs if it wanted to. And so we think we're not only going to have our regular web tech, but we're making it work even tighter with the hardware. Cloud native investments, we think we're one of the best platforms for building microservices. And I'll show some cool stuff in one of the demos that talks about that. And then, of course, what we find is about every version of .NET so far, we get about 10 to 15 to 20% more performance in a lot of the common APIs. And so this will continue again in .NET 6. We get the chance to run this tech on huge workloads at Microsoft, which helps us actually work on that. So what are the big features in .NET 6? We have a bunch of features in C# that let you write less code, less typecasting, less stuff. Super exciting to see some of that stuff. We have .NET Multi-Platform App UI. Who can come up with better acronyms than that? Which we just call .NET MAUI, but that is cross-platform, Windows, Mac, Android, iOS. Single app, all those places, and you see some demos of that. Blazor, you can now build Blazor on the desktop with full access to your machine. We have minimal web APIs. If you compare like an ASP.NET application to something like Express and Node, we look more complicated. Well, that's because we built for thousands of APIs, not 5 or 10. Now we do both. We've added more support for new chips. Apple M1 support is there now. And all of our desktop frameworks, the older desktop frameworks now run on Windows ARM64 as well. And then I think the biggest one, which is too far down this list, is Hot Reload. And I'll show a video of Hot Reload, and I'll do a demo of it on my machine in a second as well, because I think it's amazing. This is a funny one too. Talk about performance. Entity Framework has been this ORM we've had on .NET for a long time. I think the first version shipped in 2008. We now have a core version of that as well. But people always say, ORMs are expensive, they're big, they use too much memory, they're slow. The fastest lightweight data access platform on .NET is something called Dapper. And it's by the folks over at Stack Exchange. They run it to make Stack Overflow work. In .NET 6, EF Core is as fast as Dapper. So we are now as fast as the lightest weight data access library on .NET. You can see here, 70% performance gain version to version. 31% faster query performance, and up to 43% reduced memory footprint. Speed comes by not allocating memory. And so I'm super excited to say you can have all those features in EF Core, but get the same performance you would on the most lightweight ORM that's out there, which is Dapper. In fact, the Dapper folks are off to go redo Dapper now to try to make it faster again, which is great for us to have this kind of fun back and forth with some of the folks in the open source. This is some of the stuff we're doing in C#, and I'll really highlight some of this in a second. We have something called global usings, which get rid, you can see here, global using system. You can define global usings and then not have to put those in every file in your application. Less junk. Improvements to lambdas. I'll show some code in a second where you can see where if you were using lambdas before, you had to typecast a lot of times. That looks bad, so we're getting rid of that. And we're continuing to go take some of the new record work we did in .NET 5 and continue to enhance it. Where you can more easily define a class with less markup. So this is what we call minimal web APIs. And this is you can write a .NET web API with this many lines of code, 3 lines of code now. And so this is a super lightweight single file built for cloud native APIs. If you have 1,000 APIs, you probably should still use our controller model, but if you just have 5, 6 APIs, this is a great simple way to build these APIs in very little amounts of code. You can see this is actually the entire app. You might say, well, where's the main? Well, we have added a feature in .NET 5 called top-level programs, no mains required. We added a feature in .NET 6 called global usings, which got rid of all the usings. And you really can just get down to this concise code that you see here. If you want, you can easily take one of these and port it into our controller tech if you want to have a lot of APIs and manage them easily. And this is going to be available with .NET 6. And so let's do a demo of this. So some of the demos today, this is kind of weird. We were getting ready for the Build conference, which was at the end of May, and they came to us and said, hey, we want you to record all these things a month in advance. And we weren't ready. We actually weren't even ready for Build, to be honest with you. And so 3 of the demos I have today are actually videos that we produced at Build, and I just can't bring 5 laptops to the show. It's too much. So I just have videos of them, but I'll show some of the hot reload stuff at the end in real demos. So let's try this. I am super excited to show you ASP.NET Minimal APIs. We first introduced Web APIs in .NET back in 2012 with the Web API project, built on top of MVC, which uses controllers, routing, attributes, conventions, dependency injection, and more to let you build enterprise class APIs on .NET. And we've carried all that technology forward to .NET 6. But we see a new trend around lightweight APIs and small microservices, and some new frameworks like Express in Node, Lumen in PHP, Fast API in Python make these super easy to build minimal APIs. We want to enable you to build the same lightweight APIs using the same ASP.NET that you know and trust, with less configuration and a path to upgrade to controller APIs if needed. To do this, we're using a bunch of new technologies. Look at this application. Using top-level programs, there is no class or main. It's just code. Using a Lambda, I can write the function in line next to my route. And if I run this, you can see that my 3-line application can return hello world to the browser. We think these new lightweight APIs are going to make it easier for you to build microservices. We think it's going to make it easier for new people to learn and build their first APIs in .NET. So I'm super excited about this. But I want to take this to the next level and show you a real API. So let me go back to Visual Studio. Here we are back in Visual Studio, and in this case, I've got 3 API projects. My minimal web API project hosted in Azure that powers the rest of the demos you'll see today. I've got my MVC web API project here as well, and I've got an Express application written in Node. Let's start off with the MVC web API, and you're going to see it's got a bunch of files: startup.cs, program.cs, and it's got its weather controller.cs. Let's dive into the weather controller. And you're going to see these APIs are based on classes that then have methods with attributes on them. Great for building lots of APIs. But if I just want to build one API, I can go look at something like the Express application here, and look, it's very concise, down to 37 lines of code to build a single API. It gets right to the point. Now, if we move over to the new ASP.NET Minimal API, you're going to see it's even smaller and more concise than the Express application, 30 lines of code. And this is because we're using new features like top-level programs, global using, and Lambdas to really reduce the amount of ceremony you have to do to write a single API. This kind of technology is great for building microservices and simple APIs. Now, as I looked at this, I wanted to compare all the technologies to each other. And so what I've got down here is I've got a notepad file, and I've kind of kept a tally of how much code you have to write. So the MVC web APIs, that's really if you want to build a lot of APIs, that requires about 138 lines of code to get started. The Node Express API uses 37 lines of code. And amazingly enough, .NET minimal APIs are only 30 lines of code. And this is just showing you we're applying these new technologies to make it faster and easier for you to build great apps. So here we are back in Visual Studio. And now what I want to do is run my app locally to make sure it works. Here we go, and you can see it's pulling the weather back. And so I've got a successful API using ASP.NET Minimal APIs running. Now the next thing I want to do is switch back to Visual Studio. Here we go. And what I want to do is I want to publish this application to Azure for the rest of the demos that you see today. So I'm going to click Publish. We'll select Azure, and we'll select App Service Linux. There we go. Let me create a new one. I'm going to change my name just to Minimal Weather. I've got a hosting plan already set up for me. I will select that. Press create here. There we go. It's creating my app service. Now I'm going to click next, and I'm actually going to deploy using GitHub Actions using CI/CD, and click finish. What happens now is when I commit my app, it will do a CI/CD flow to publish it. I can switch to my repo, and you can see all the steps have happened to publish my app to Azure. And now I can actually go and open my browser tab here, and this shows the minimal API that we built running in Azure. And we will use this for the rest of the demos today. So that is minimal APIs, and some of the inspiration for that was Maria Nagaga on our team, who joined our team not as a .NET person and was like, wow, you know, getting started in .NET's hard. Building these controller APIs is so much more complicated than the examples you see in Python and Node.js and such like that. And so we built language features to enable this, and this is all using the same ASP.NET tech. It's the same tech that powers the controller APIs. It's just a more simple, concise way to do it for people to want that. So very, very cool about that. The API we built there was a weather API, and then all of the other demos I have here use the exact weather API. So the next one we have is .NET Multi-Platform App UI, or really .NET MAUI. What this is a platform for building cross-platform native UI with .NET. Notice here that on Windows, we use WinUI. WinUI is the newest tech built in the Windows operating system, Windows 10, for building GUI applications. On the Mac, we use something called Mac Catalyst. Mac Catalyst is an API or a library on the Mac that's designed to make it easy to move an iOS app to the Mac. Apple themselves uses Mac Catalyst for many of their apps, like News and so on the Mac. And so this is the same tech Apple's using to build their apps, which makes it very easy for you to build apps that run on the Mac. And then, of course, for iOS and Android, we use the native libraries on each of those devices as well. So we have all four of these supported. Not only that, if you've ever used the Xamarin technology we had in the past, it actually has a project for every one of your deployments. So we'd have 4 projects here. And so we are going to condense that down. You have one project that supports all these 4 app types, one single code base, write once, run everywhere. And you can deploy to multiple devices. You just right-click on the application and tell us where you want to build a deployment for, and we'll do that for you. And this will ship in .NET 6 as well. And this is exciting tech. Not only can you do this, but one of the neat aspects of MAUI is you can also make your apps work better on the native platform. So the demo I'm about to start, we will build a MAUI app, which is kind of a common app that runs the same way on every platform, and then we will enhance it. So if you run it on Windows or a Mac, you're getting all the things you would expect. It can do native notifications. It can do right-click menus. It can do taskbars and stuff like that. So let's do a demo of this as well. .NET 6 brings consistent experiences from all project types to .NET MAUI, including the command line. In this case, we're going to create a new MAUI app with .NET New MAUI. We're going to name it Build MAUI. Now from here, I could run, if I wanted to, .NET Restore, .NET Build, .NET Run, but I want to show you how we can build an optimized experience for building cross-platform applications with Visual Studio. So let me launch Visual Studio here. .NET MAUI targets iOS, Android, Mac, and Windows. And so what we're going to do here is take the single project here. We're going to set this to Startup Project here. And then what I want to do is I'm going to go to the debug menu here. And let me click that again, drop that down, and I'm going to select the framework that I want to run on. And I'm going to select Android here. And that means when I run the application, it's going to actually run the application on my Android emulator on the right here. So let's get this started. One of our goals with .NET MAUI was to give you a single project for building all your applications, so you can focus more on your application and less on the specific targets of your application.
It all starts with the startup.cs file. This is very similar to what we do with ASP.NET today. This is where you configure all of the things for your application. In this case, we want Xamarin Forms compatibility. We set our default application. We're going to set our font right here. And if I'm using third-party libraries, I would configure them here as well. Maybe I'm going to use dependency injection. I want to share something across my application. I would put that here as well. And so that's kind of the way we've copied that experience from ASP.NET to over here. Now we all have these folders: Android, iOS, Mac Catalyst, and we have the WinUI 3 down here. And this is where you write your platform-specific code. We also have a resource folder. Inside of that, we put your fonts, your images, your app icon, your startup screen, all in one place. And so here the application is booting up in my emulator. And what I'm going to do is I'm going to go and click the counter here. See, it's at number 5. And I'm going to show you a hot reload. I can actually change either my XAML or my C# and press save. And as soon as I do, the application updates immediately. This helps with your productivity quite a bit. Now this is a semi-simple application. Let's use a more complex example and show you how we can do platform-specific light up with .NET MAUI. So here I am in Visual Studio with my weather application. And you're going to see that as I run it here, it's a WinUI, native Windows application. But I've done a few things differently here. If you look in my configure services, I've added some new services. I've added a tray icon for putting a tray icon on Windows. I've added notifications for native notifications and a tray icon for Mac. Now, if I go and show my main page here, you can see what I've done is set up app actions. This allows me to put a context menu when you right-click on the app icon, where you can put some menu items in here and make it do some other options. I've also added a tray icon too. And so what happens here, if you click on the tray icon, we'll send a notification on the platform that you're on with that data. So if I look here, I can right click here, my new context menu showing up right here in my applications. It's showing native UI hookup. Here's my tray icon. I can click it. And there you go. You can see as soon as I did that, a notification popped up in Windows. It's just showing how you can do these native light ups across all the platforms. Now, I can't just show you just Windows. .NET MAUI is cross-platform. Let's go to my Mac and I'll show you a couple other options. Here you go. I've got my same UI and same code running on iOS, macOS, and Android. If I resize the macOS application, you see it resizes dynamically like you would expect. If I click the icon, you see those same menu items there you saw before. And then if I click the icon at the very top, you'll get that notification directly on your Mac. So this is showing you how we could do this cross-platform light up, but still give you these native options with .NET MAUI, all using the same UI.
So I hope that was cool. I think, write once, run everywhere, using the native platform UI on all those apps is a friggin' amazing capability, and I am super excited about it. I cannot wait to ship this in November. The next thing we thought about was Blazor. A lot of the apps we use today, whether it's Slack, whether it's VS Code, these are, what we call Electron applications. They're web apps that run in a desktop shell. And of course, they need that desktop shell so they can talk to like the file system. VS Code is in file editor. It needs to be able to see your file system. But using web is great because you can use your web and share it across all these different platforms. Some people just prefer to write their UI in web. And so we love to give you that native capability again with Blazor. And so once again, you can reuse UI components across native and web. What I don't say here is you can actually put native controls in a Blazor app as well if you want. You don't have to just use web. You can do a mix of web and native controls. This is actually built on top of the thing I just demoed before, which is called .NET MAUI. It's basically .NET MAUI, but inside of .NET MAUI, you have in your XAML, you reference a Blazor project, and that will inject the Blazor project directly into your application. Something cool is the Blazor project is running in proc with the application, which means it is super fast, and it has access to the whole device. Once again, it's a native app container, which means it can have native controls as well. And this will ship in .NET 6. And you can see right now, we're primarily targeting Windows and Mac for this, but it will work on iOS and Android. I just don't know if we're going to put supported next to those in this time frame. But the tech is the same tech, so it should actually work across all those. there might be a few limitations on the mobile devices if you want to build a web-based app that runs in all those places. And then here is a demo of Blazor. And we're going to start off with, before I start the demo, we'll start off with just a plain Blazor application, a web app. And then we'll take that Blazor application and wrap it into a native app. And then we'll give it those same native hookups that we gave the real .NET MAUI app as well, because it can take advantage of the system platform.
Blazor makes it easy to build rich, modern web UI. Here's our weather app implemented as a web app using just HTML, CSS, and .NET. The web app has a nice responsive layout, so it looks good on mobile devices as well as desktop screens. We can see the current weather and local weather forecasts. We can also check out the weather from other locations. Here's the weather in South Korea. Here we can also change the settings of the app to switch from imperial units to metric units, and it automatically gets applied to the entire application. Now, all of the client-side interactivity in this app is implemented using reusable Blazor components that work in any modern web browser using just the open web. The app calls our Azure-hosted minimal weather API to get all of its weather data. By pairing Blazor with an ASP.NET Core server, you can build full-stack web apps with just .NET. Our weather app can still use some improvements. The list of weather stations on the right-hand side looks a bit plain. In .NET 6, we can quickly make changes to our ASP.NET Core and Blazor apps using .NET Hot Reload. Here's the component that displays each weather station. As you can see right now, it's got some simple markup. Let's update the styles for this Stackbox class. Save that. It gets automatically applied. Looks nice now. Let's also add some markup here in order to better lay out the text and maybe add an icon. Save that. With .NET Hot Reload, our changes get applied to the running app without losing any app state. Blazor makes building web apps with .NET fast and fun, but sometimes you need more than what the web platform offers. By combining Blazor with .NET MAUI, you can reuse your existing web UI logic and web development skills to build cross-platform native apps that can take advantage of the underlying platform. .NET MAUI comes with a built-in Blazor Web View control that you can use to add existing Blazor components to any .NET MAUI app. This means we can take our Blazor components from our weather app and embed them into the .NET MAUI app without having to change anything. Here is our weather app running as a native desktop app on Windows. It looks the same and has exactly the same functionality using the same Blazor.NET code. Blazor components hosted in .NET MAUI run directly in the .NET process. This means they run fast and have full access to the native capabilities of the device through the .NET platform. For example, we can reuse the same system tray integration that you saw previously and trigger native platform notifications. Because this Blazor app is running inside a .NET MAUI app, it can run on other platforms too. Let's switch over to my Mac to see how Blazor desktop app can run cross-platform. All right, here's our Blazor weather app running as a native Mac app. As you can see, it's got the same look and feel. It's got the same functionality. If we check out the weather in South Korea, we can do that. There it is, and it looks and feels the same because it's the same code that we ran in the Windows app and also on the web. The app also has native integration, so it can show the little .NET bot up in the menu. We can click him and trigger a native notification. By building our app as a Blazor hybrid app with .NET MAUI, we get the best of .NET, the best of the web, and the best of the native platform.
So that is .NET MAUI with Blazor. Something else that's really cool about that is these apps, which we've not even worked on actually optimizing yet, are very small in memory footprint. So we all know that some of the Electron apps, including Teams that I'm running right now, can end up using a lot of memory. The native version of the weather app was using about 80 megs of RAM. The Blazor version of the same app was using 95 megs of RAM. So under 100 megs of RAM for a real functional application with real UI with web. And so we think if you're a .NET developer, whether you want to use native UI or you want to use web, we have you covered with both of those techs. You can do more with .NET. Now, let me define a term. There's a term that we use inside of Microsoft, and none of you would ever use this term. I never heard of it until I worked at Microsoft. And we have a term called inner loop. And the inner loop is the loop that we as developers do. You write some code, you run your application, you look at it and go, yuck. You stop the app, you change the code again, and you reload and you rerun the application. That loop of making a change, seeing it reflected in your application, and then doing it again and again, we call that inner loop. And so one of our biggest goals in .NET 6 is to work on the inner loop. You know, you've seen on the benchmarks that .NET is amazingly fast as a runtime, but our inner loop performance is not good. If you compare us to Node.js or a React app or a Flutter app, they just have a much better developer feel. In some ways, because some of that tech's not compiled tech, it's actually interpreted, and so they don't have to restart apps and do stuff like that. But this is something we want to fix in .NET. And we've already made more progress than I ever thought we would have in .NET 6, and we'll continue with .NET 7. You can see just generally across the board, just a clean build of a Blazor server is less than half of what it was in .NET 5. Incremental builds are much faster. And then for MVC applications, basically you can see here that even before we even start talking about doing what we call hot reload, we've improved this amazingly across all these things. So lots of build time improvements, and we actually had to stop doing these. We had more. We can make each of those purple bars a little smaller, but we ran out of time. Even though we're 6 months from shipping, we need people to go work on some other stuff. But in .NET 7, we'll take another hit of this and remove more of this. Hot reload. And if you don't know what hot reload means you just change your code and the app updates without doing a stop, recompile, run. And we've had parts of this in some tech for a long time. We've had edit and continue, which worked for WinForms and WPF projects and web forms projects. But we want to make this tech work everywhere, whether you're building a console app, a Windows app, ASP.NET app, a MAUI app. We want this to work everywhere across all the project types. And this is a big thing. We don't want to restart your process. So we want the state to maintain, so your app stays where it was before. You saw that in the demo of the Blazor desktop stuff. And there will be cases where we do have to restart the app, but we've actually figured out how to actually restart the app without killing the process, because processes are expensive in Windows. And so we can do that too. And then here's another thing too, is if you've ever used edit and continue, it requires you to use the debugger. I never start my .NET apps with a debugger. I always start with Control F5 because it's a faster experience. And so we're going to have a new experience where you can actually start this, get the hot reload, and then if you decide halfway through your session to add the debugger, you can. And this will be an evolution of edit continue. And I'll do a demo of this real quick. All of the stuff I'm showing that I said was undimmable should be dimmable maybe in a week from now on bits that we're going to release to you folks. But here's hot reload.
For this demo, I have two apps to show you. First, let's start with the WPF app running on the right-hand side. This is a .NET 6 app called Voids, a game of life simulator, and you can see many shapes moving around. With .NET Hot Reload, we can now change the game logic while the app is running. To do that, we're going to press this brand new button. Now let's go ahead and make a change to the app and see how it works. I didn't build the app, so I'm not sure what changes to make, but let's go ahead and change speed limit. That seemed like it's going to do something. So I'm going to go ahead and change that. How about we add 10 to it? Now I'm going to apply the change. And as you can see, the behavior of the game is changing right away. I'm going to undo that. I'm going to make a different change. I'm going to make a change to the percentage to move towards home. Not quite sure what that's going to do. Let me just add 0.1 to that. And again, I'm going to apply the changes. And now you see a dramatic change in the app without having to restart it. While it's fun to show you an app like this, I now want to go back to our weather app and show you some edits that should feel like real world situations. Let's switch over to our weather app. Here's the weather app you've seen in the other demos. As you know, this is a .NET MAUI desktop application, and here too we can apply code changes while the app is running. So first I'm going to look at the wind indicator. I expected some simulation code to have been added to make the indicator move. Let's go ahead and see what happened. I'm going to go look at the code and find there's a to-do here. Instead of stopping the application, I'm just going to go ahead and add the code that I would have expected to be here. I'm going to add a get direction, which gives me some random directions. I'm going to change it so it applies the direction icon, and I'm going to apply those changes. The indicator starts to move. For favorites, I'm going to go ahead and click that button. And it seems like something is missing here as well. So let's go look at the view model. Well, I have some properties here, but it seems like I have no logic to load the data. Let's make a change that's needed. Now I could have typed this, but just to save us some time, I'm going to paste the code in. It should have been here. And you can see we have a constructor, an async method, private method. All of this can be applied to the running app by hitting the apply code changes. Switching back, I can go ahead and switch to the home screen, switch back to favorites, and now I see the data. But I see one last bug. It's only loading Redmond. Let's go take a look. Yes, would be easy to miss. It should be an I instead of 0. I'm going to apply those code changes and navigate back and forth. There we go. And now we get all the data we expect. Now with this app, it easily could take 15 to 20 seconds to restart the application. And it's a small demo app. But with Hot Reload, we were able to make all these changes without having to restart the app a single time. Imagine how much time it will save you.
Cool. And that's Hot Reload in .NET 6. I want to do one thing here. Sometimes I think like the videos don't have enough of the flavor of this. I want to show this in person. So this is, I'm not even going to show it in Visual Studio. I'm going to show it from command line. So I've got a Blazor .NET 5 application here, which I can run. Actually, let's do this. And it should launch the browser, I think. I don't know what state of. Huh. Well, I can work around that. Normally it would actually launch that for me, but let's just do this. We can control click, bring it up. Here's a Blazor app, and I can come over here and put this over here, put this over here, and we can make changes in this. This is a .NET 5 application, so let's go to the counter page, and we can say the dev intersections. And I don't think it's going to actually refresh for me because it's not doing the refresh model. Sometimes when you have too many beta bits. I know the 6.0 one will work, and I'll just go and show the 6.0 thing here. So let's just cancel that out. I know 6 will do what I want. So the 6.0 one's launching. Notice it says hot reload enabled. Launched at the browser. And if I was smart, I would have actually here's the code. So I've got my Blazor app, and I've got a VS Code running. And let's take a look and see what the perf is to update this application. So we'll go back to the counter page. And let's say in .NET 6, give it a second here. Now what I'm going to do is I'm going to add a couple exclamation marks here, and I'm going to press save. Now. Take those back away, press save now. That is instantaneous. Let's click the counter. Okay, I went to 10. Now let's go change the code to go by 2. I'll press save. And now we reset the app. The app actually blinks a little bit. It's reset. And it kept the state. Notice it still says 10. And it's still there. If I click the button, it now goes up by 2. So basically, you can make markup changes, you can make code changes, even from the command line, and we can update these things instantaneously. In Visual Studio, it's even better, because in Visual Studio, we're actually running code to actually run IntelliSense. We're compiling your code as you type. So when you press that apply button, we take the code we've already compiled in memory and just inject it directly into the running application. And so it is sub 100 milliseconds. And to me, this is one of the biggest missing pieces of .NET. We've, as I said before, we've had great runtime performance. We've not had the best inner loop performance, and you're going to see us take this as serious as we've taken any of the runtime performance as we move forward. And so I'm very happy with that. And with that, let's go back to slides. Preview 4 is available today with MAUI support in Visual Studio. You can build the Blazor desktop applications. There's some templates with minimal APIs. And so I would ask people to go to .NET/get.NET 6 and grab that preview. We plan to ship, I should talk about this too. We have this ML.NET library that does machine learning. It's actually a library used by Office. And if your machine supports Windows Hello, that's where you can log into your machine by your camera. That's all running this tech. And we've added support for more architectures to it as well. We've added ARM64 and M1. This means you can now run ML.NET inside of Xamarin projects on iOS and Android. We have this cool tech that's in the picture here called Model Builder that writes a lot of the code for you and helps you train your models and stuff like that. And before it was kind of every time you went through it, you had to restart the whole thing. And now it's actually reentrant. You can go back and retrain or change some parameters and do those types of things to make your tech work. And we have a feature called AutoML there as well, which will pick algorithms and stuff for you automatically. So there's a bunch of improvements in ML.NET. And then I really have to say is we're going to ship everything I showed you on November the 9th. And we have our own virtual conference on November 9th as well called .NET Conf. It's our 3-day event that's both, it's about half Microsoft and half community, where we will show and talk about all the new stuff in .NET 6 that will ship that week. So that's .NET Conf. And so, thank you so much for coming out. I want to say something as Richard said when he kicked off, this is the first in-person event I've been to in over 15 months, I think. I think January of 2020 or something was probably the last one of these. And so I want to thank everybody for hanging in, coming out. Even Microsoft, there's a couple of us, there's Scott Kate and myself from Microsoft. We have no travel budget because with COVID, the company was like, well, we don't need anybody to go anywhere because there's COVID. And so it was even hard to get money to come out here and see you folks. But I really am happy to be here. I'm glad we have an in-person event. Thank you for supporting the show. And with that, I will also say there is a new in-person show that will be this December, probably on a much bigger scale than this, because we will be 6 months more into vaccinations and stuff like that. So thank you so much. I have a session later today where I'll go deeper dive on a bunch of the .NET stuff. If you want to come and attend it, I think it's at noon. But thank you so much for coming. Hope you enjoyed the content, and see you next time.